You don't have the chart on your worksheet? It might just have not opened properly. It's not too big of a deal, Taylor. What's more important is that you have your formula sheet with all of the conversions in the table at the top of your formula sheet. So if you have that, that's good. That should get you where we need to go today. I'm just going to go through all of this stuff anyways, and I'll write down all the conversions, so don't worry about it too much. So looking at the question, the field's 59 meters wide, and we need a measurement to the nearest foot. So what I'm going to do is I'm going to start with 59 meters, and I'm going to use a unit conversion. So I'm going to multiply that by something. Now, I need to get the meters to cancel out, so I'm going to put it on the bottom, and I want to end up with units of feet, so I'm going to put it on the top. Now I go to my formula sheet and I look up the relationship between meters and feet, and it tells me, this is directly off the formula sheet like I wrote up above. I'm going to write it again. 1 foot is equal to 0.3048 meters. And this is from the formula sheet. Might get in the way. I'm going to erase that. So that's the conversion factor that we're going to use. So we're going to just plug that right in here to our equation. So I have 1 foot is 0.3048 meters. Now at this point, I just need to do the math. So I'm going to multiply my tops. Now this 59, I could write it as 59 over 1. I don't need to. I know the one's there, so I'm just going to get rid of that. But you could, if you wanted. When we multiply fractions, sorry, I'll go back up here for a second. When we multiply fractions, we go top times top, and then bottom times bottom. So we had a field was 59 meters long, or wide, sorry. We're going to multiply that by the 1 on the top, and then we're going to divide by the bottom. So scroll back down. Abby, you got that? So 59 times 1, and then divided by 0.3048. Now we don't need to multiply by the 1, so I can just divide by 3048. And I get 193.56. The question asks to the nearest foot, so that's just a whole foot value. So if I ended up with the right color, 193.5 feet, it's asking for the nearest foot. I'm going to just round to the ones column here, and I'm going to end up with 194 feet wide. So all I've done is just taken my conversion factor from the question off my formula sheet, going from meters to feet. I've just multiplied it and converted to feet. So there's only a couple more questions. This stuff's pretty straightforward, really similar to the sort of conversions that you guys did before. The next question is kind of a two-parter. Two people are driving. So Timmy drove 144 kilometers. Seth drives 68 miles. And again, this is kind of one of these things that they do to trick us from time to time. We're using two different units here, so kilometers and miles. So there's two ways to do the problem. We can convert them both distances to miles, or we could convert both distances into kilometers. And you can do whatever you want. You just need to compare the two at the end because it's asking who's driven further. So method 1, convert Seth's distance into kilometers. Method 2, convert Timmy's distance to miles. I'll just I'll do them both. You pick one. Half of us do one, half of us do the other, see how we end up. All right, so the first one, Seth drove 68 miles. So I'm gonna start with that, 68 miles. And I'm gonna have to multiply it by some conversion factor. I want to get rid of miles, so I'm going to put miles on the bottom. And I want to end up with an answer in kilometers, so I'm going to put kilometers on the top. I'm going to go to my formula sheet at the very top, unit conversions, and figure out the relationship between miles and kilometers. So again, right off my formula sheet, I'll just write this over here on the side, because we're going to use it for both parts. 1 mile is equal to, approximately equal to 1.609 kilometers. So that's the ratio I'm going to use. So I have miles on the bottom. I have 1 mile, so I can put the 1 on the bottom. And that is equal to 1.609 kilometers. So kilometers just a little bit longer than, or sorry, miles a little bit longer than kilometers, so we're going to multiply here. 68 times the 1.609. And then I'm going to divide by 1, which I don't really need to do because I know it's just going to give me the same number. So I get 109.412 in my calculator. And because I'm going to compare these two numbers, it's important to maybe keep a few decimal places, although it's not terribly important. Just a reminder, I have miles on the top and the bottom, so they're going to cancel one another. And then I'm left with kilometers as my units. Just looking at the question, Timmy drove 144, Seth drove these 68 miles, and it turns out 68 miles is the same thing as 109 kilometers. So if I were to say who drove further, it actually looks like Timmy had drove a little bit further. So if I just wanted to end that here, I could. And I could just write, Timmy drove further. Now, this question was a little bit, nothing's showing up. Naomi, are you in the live stream as well as the chat? So going to, back to the course and then clicking on the little studio there to bring up the live feed. Maybe give me a second. Hopefully everybody can see everything going on. Me in my lovely striped shirt. Yeah, Abby's on it as well. Naomi, let me know if you can't get it going on the live stream. I'm just going to keep kind of plugging away. I'm going to do the second half of the question kind of quickly. So Timmy, we're going to convert Timmy's into miles. So if I had 144 kilometers. I want to get rid of kilometers, so I'm going to put it on the bottom, miles on the top. I know the conversion between kilometers and miles is 1 mile. It's 1.609 kilometers. I'm going to cancel my kilometers, be left with answer in miles. And I'm going to take, on my calculator, 144 divided by 1.609. Gives me 89.49 miles. Uh, 89 is definitely further than the 68, so same answer as before. Timmy drove further. So there's 2 ways to do that question. It's okay, Naomi. I can tell you you're not the first person to do that, and it's really strange, and we are looking at ways of bringing both the live stream and the chat together, but we're not quite there yet, and this is kind of what's working best so far. The good news, Naomi, is that everything's taped, so if you want to go back, you can watch the first 5 or 6 minutes of the lesson, and it'll all be there online this afternoon. No worries. All right, the next question. DeMar DeRozan, basketball player, 6 feet 7 inches tall, convert his height to centimeters, estimate to justify your answer to see if it's reasonable. It's always a good habit to kind of take a second and think about your answer. Does your answer make sense? So that's kind of where we're at here. See if I have this one. So what we're going to do is maybe we should just convert. Well, there's lots of things we can do. For me, it makes the most sense to go from, because 6 feet 7 inches is in both feet and inches. And it would be kind of nice if we converted this maybe just to inches, because from inches we can convert to other things. But if we have a number in feet and inches, it can get a little bit confusing. So we could convert the 6 feet 7 inches to a decimal amount of feet if we wanted, or we can just convert it all to inches. And that, to me, is kind of the easiest way to do it, because that way I'm not dealing with decimals or anything like that. So what I do know is that there are 12 inches in a foot. So if I have 6 feet times 1 foot, to get rid of my feet is 12 inches. 6 times 12 is 72 inches. So the 6 feet is the same thing as 72 inches. So if I had 6 feet 7 inches, I'm going to convert that essentially just into pure inches. 6 feet is 72 plus the 7. I'm going to end up with 72 plus 7 is 79 inches. All right, once I get here, I need to convert this to centimeters. So again, I'm going to go to my formula sheet, and then I'm going to figure out the relationship between inches and centimeters. So right off my formula sheet, let's see, I have 1 inch is equal to 2.54 centimeters. So that was just right off my formula sheet. I'm going to use that conversion factor now to convert the inches into centimeters. So I have inches on the top. I want to get rid of them. I'm going to put them on the bottom. I want to end up with units of centimeters, so I'll put them on the top. And in this case, I know 1 inch is 2.54 centimeters. My inches cancel, left with units of centimeters. So I'm just going to plug it into my calculator. 79 times 2.54. That gives me 200.66 centimeters. Now the question isn't really specific. 483, or 438, sorry. Maybe I made a mistake. I'm going to double check mine. 79 times 2.54. I definitely get 200.66. That's all right, Damon. I'm going to convert it just to a 1 whole centimeter, so it's going to be 201 centimeters if I round to the ones column here. Now, the question also asked us to estimate to figure out if this makes sense. All right, so Abby and Taylor are both kind of getting the same thing as me, so it looks like I didn't make a mistake. Damon, did you figure out what you did wrong? Maybe it's just like a calculator error, transcribing it into your calculator or something. So 2 meters. If you think about a meter stick, how long that is, I took my meter stick out of here, but 2 meters, about the height of a person. This person's 6'7", they're a basketball player, so I would go with 2 meters probably being accurate in terms of the height of a very tall person. So that kind of makes sense to me. Hopefully it makes sense to you. We're happy with our answer. Is this the last one for this lesson? I'll leave that up for a second. So the next question here reads, when you're driving under a bridge, you'll notice that most bridges have those clearance signs. And they tell you, how high you can be. Now, there's general standards for heights of these overpasses, but in this case, you and your truck are 3.5 meters high, and it says the clearance is 11 feet 9 inches. Would you be able to fit under the bridge? So again, this is kind of like the distance-driven question from up above. We could convert the meters into inches, or we can convert the inches into meters, but we need to have them in the same unit. Oh, sorry, this is 11 feet 9 inches. We need to have them in the same unit in order to compare them directly. So again, we can convert this to meters if we want, or we can convert this into inches. It really doesn't matter. Inches and feet, I should be more specific there. What I'm kind of always inclined to do is convert my feet and inches into meters. It's just my personal choice. Maybe if somebody wants to do it a different way, the other way they could. No method is more correct than the other. So don't think, oh no, I've converted my 3.5 meters into feet and inches and that's wrong. Definitely not. This is just how you've chosen to do it. So I'm going to start with 11 feet 9 inches. And much like the question 2 questions ago, or no, the last question, the 6 feet 7 inches thing, 11 feet 9 inches, we need to make sure that we have just one sort of number here. So not feet and inches, but maybe just inches. So I'm going to take my 11 feet and I'm going to convert this. I know I have to get rid of feet, so I'm going to put it on the bottom. I have inches on the top. I know that 1 foot is 12 inches from my formula sheet. And if I take 11 and multiply by 12, I end up with 132 inches. So that 132 inches is just the 11 feet part of this. So what I'm going to have to do is I'm going to take 132 inches and then add 9 more inches to it to figure out this entire number. So we end up with 141 inches. Once we get this far, I'm interested to see if we have enough clearance. So it's 141 inches high. I know my truck's 3.5 meters high, so I need to figure out exactly where that falls. So what I'm going to do is convert my inches now into meters, or I might have to do a 2-step conversion. So in this case, if I look on my formula sheet, for all my conversions that I know, just looking at the top on the formula sheet, I don't see anything that goes right from inches into meters. So I can see that an inch is 2.54 centimeters, but I don't have a direct conversion from inches into the meters. So what I'm going to have to do is do 2 steps. So I'm going to start with this 141 inches, and I'm going to convert my inches into centimeters, and then from centimeters I can go into meters. Now, you could do this in 2 steps, or you can do it in 1. It doesn't really matter. But I do know the relationship between inches and centimeters is 1 inch is 2.54 centimeters. So I could write an equal sign there and then do a second step. But what I'm going to do is just live life a little bit dangerously. And I'm going to go ahead and convert my centimeters to meters. So if I have centimeters on the top here, they're going to cancel out and I have meters left. My inches have canceled out. And the relationship between meters and centimeters is, I know that 1 meter is 100 centimeters. All right, so what I'm going to do is multiply all my tops together and then divide by anything on the bottom. So when I'm going to punch this into my calculator, it's going to look like 141 times 2.54. Then I'm going to multiply by 1, but I don't need to multiply by 1. So what I'm going to just end up doing is dividing by that 100. And then Alex was a few steps ahead of me. I end up with 3.58 meters. So now I need to just take a second and kind of think about what I just calculated here. The clearance is what I started with, the 11 feet 9 inches. And the clearance ended up being 141 inches, which was equivalent to 3.58 meters. So if I have my overpass here, I know that it's 3.58 meters from the top to the bottom. Now I will try not to draw too many pictures in this class because my artistry skills are not good. But just to give you an idea, here's my truck, the back of it, and I know my truck is, from the top to the bottom, is 3.5 meters high. So is it going to fit in there? It looks like it will. How many centimeters will I have to spare? If you've ever driven along, if you've ever driven along a highway, if you watch those big trucks go under those really low overpasses, sometimes there isn't a ton of room at the top, and they know exactly how tall their trucks are and how high the overpasses are on their way. There's lots of examples of trucks running into overpasses, but maybe the more people that are unfamiliar. So yes, it will fit. We have 8 centimeters to spare. Gonna put a little bird on top of that thing or something and fit under there. So there you go. Now this section was just kind of a quick little section converting back and forth. It's just kind of taking all the stuff we've done, just making sure you kind of understand the unit conversion stuff, going from feet and inches to just inches, and then taking those inches and converting to the metric units. The kind of key here is that you're using your formula sheet. So the table up at the top has all the information you need. Don't feel like you need to memorize it or anything like that. You will have this for tests, quizzes, final exam, everything on the formula sheet. So make sure you're using this. That was one sort of thing that I wanted to go through. The other thing I wanted to go through was on the vernier caliper. So this is a measurement tool. It's sort of, it's closed. Do we do lesson 2? I'll go back to the course here and we'll have a look. Don't want you. There we go. So maybe yours is hidden, it's possible. So what we just did was lesson 2 worksheet. We just went through that. This afternoon, after I'm done blathering at you, if you could go through the lesson 2 practice, that would be superb. That's just kind of the questions we've just been doing. All the solutions to the practice questions are in here, as well as some further explanations if you need some help there. This caliper simulation is an actual sort of flash animation. Let's see if I can get it running on my computer. There we go. Move it over so you can see it. Forget Mr. Ross to go full screen behind me here, get me out of the way. The way this thing works is you can click and drag on the caliper here, and it's gonna go ahead and measure things. Now, I seem to have lost my objects down below. There they go, popping up. So I can drag in a bottle lid, and it measures how wide things are. Now, why would I use a caliper as opposed to a ruler or a measuring tape or something like that? Calipers are very accurate. You'll notice this one is measuring here to point, this is all centimeters. So we have 2 centimeters and then we have 0.19. So it's actually measuring to the nearest millimeter, which is way more accuracy than we would use or get out of a ruler or something like that. So Abby, your dad, if he does any sort of building that needs to be accurate, he will. Now, I tried to find a caliper at home and I don't have one, but my son, who's 3, he has a plastic set of tools with hammers and saws and things like that, and he had a caliper. So I brought it in to kind of show you how it works. You'll notice the one that I have here, it has this little dial in the middle instead of the sliding scale like behind me. But just to give you an idea of how this works, and Abby, you've probably seen this happen before. So if I have my mug here, if I wanted to measure the outside of my mug, I would open up the caliper here, and I would just close it down on the mug, and I would then read off the scale. So what we're going to practice doing today is reading the scale. You'll notice that there's, you can put things around the outside here, and then on the top, if I flip it upside down, you won't be able to see the scale, but you have these two, and if I want to measure the inner diameter of something, I would just open it up within something, and that gives me an idea of how wide the inside is. And then I could measure the outside with this, on the outside like that. And if you have a really nice set of calipers at home, what you'll see is that on the end of it, there'll be a bar that comes out here. So as you open it, the little bar will kind of make its way out the bottom. And then you could measure the depth of things. So you can stick that bar into, if you had some sort of socket or something, you needed to figure out how deep it was, you would just slide it down, and that would tell you exactly how deep something is. So the reason we'd use a caliper is for extremely accurate measurements. Nowadays, if you go to a tool store, Canadian Tire, Princess Auto, wherever, most of the calipers are going to be completely digital. So you don't have to bother reading anything anymore. You just close it on whatever you're trying to measure, and it'll tell you exactly the distance in digitally, so you don't have to bother reading. Yeah, you don't need to have one. Definitely not. The thing is, you need to be able to read one, which is kind of interesting. So what we've included in the class here behind me is this digital one. There's two things you can play with here. There's this a hex nut, and you have this bottle lid, and you can flip it to measure the width of it. You can slide it in here. The one thing about this simulation is it tells you exactly how wide the object is, and you don't really have to read anything. So what I've done is I've included in the course a few examples of reading this. So if you don't have this printed off, it's not really the end of the world, but I just wanted to make sure we can figure out exactly how to read one of these calipers. So I'm going to bring up the vernier caliper lesson. And I'm going to show you guys a bit of how we read these things, because it can be a bit tricky. So you kind of saw what it looked like. I have my nice fancy plastic one. There's some instructions here that tell you how to deal with it, but it's a little tricky. So let's look at a couple examples here. So the first example asks us to read the following caliper measurement. Now, there's a lot of stuff going on in terms of these numbers. We have a number scale along the top here. We also have a number scale along the bottom here. And it can get confusing. So the idea here is this. The numbers along the top, this is 10, so this is measuring in millimeters. The numbers along the top here are going to be centimeters. And then down here you can see this is kind of got cut off. So this is 0.1 millimeters. So that's going to give us a tenth of a millimeter, which is way more accuracy than we'd get out of a tape measure or a ruler. So that's kind of the advantage here. So if you can imagine I had an object, I don't know, let's pretend I have like a bolt, and I've stuck the bolt in here, or a nail or something, some threads, and I want to measure how wide it is. Now, just like on a ruler, kind of looking for this 0 here. So this is the area I'm looking right now. So I can see that this is, the distance along here is 1 centimeter. This is another centimeter. And then I haven't used up this 3rd centimeter, but I've kind of running in the middle-ish of it. So these are all millimeters. I have 1, 2, 3, and then 4. And then the 0 is just past the 4. So what am I starting with? Well, I have 24 millimeters to start. Once I've established where the 0 kind of falls on the scale, I need to then go to the very small scale down here. So this stuff at the bottom. Now the way this works is, you'll notice it's kind of weird, but these lines kind of, all of these little marks, they kind of line up with the numbers above or they don't line up. So what we need to do to figure out exactly what decimal we're dealing with is to figure out which one of these lines lines up perfectly with a line above it. So you can see over on this left by the 0, this 0 is to the left of this line. This 1 is getting kind of close. And then if I look way over here, the 10 is way off, and the 9's way off, and the 8's way off. So I need to figure exactly which ones line up. Now, it's not always going to be 100% obvious. Abby put in a 2. Does anybody agree with Abby, or can you see one that looks like it's lined up a little bit better? Give you guys a second to look at that. Abby seems to think the 2. Sometimes it can be hard to tell. You're going to just have to do your best at estimating. Jade agrees. You know what? I think I'm going to agree as well. It definitely does look like the 2 is kind of the most lined up of all of those. So what that means is it's 2 millimeters. So I'm going to have this 24, and then I'm going to add to it, and this is 0.1 of a millimeter, so 0.2 millimeters. So how long is this bolt or whatever I'm measuring? It's going to be 24.2 millimeters. So I'm happy with that, if you're happy with that. I'll just scroll down here to the next one. We're going to do the exact, Jade asked, why is 24 millimeters isn't the top centimeters? Not sure if I exactly understand what you're saying, but if I look at the top where this lines up here, you can see that it's 21, 22, 23, and then the 0 is 24. And then what we're doing is, if we had like a super magnifying glass, what we'd be doing is figuring out where that 0 falls within this gap in between this line and this line. So if I had to estimate just based on where the 0 is between this, so if I were to divide this little space here up into 10 parts, where would it be? So it's kind of looking like it's closer to the 24. So it's going to be a small number. In this case, 2, the 0.2, kind of makes sense because it's not really close to the 5 here. It's more close to the 4. So 1 to 10 millimeters is 1 centimeter. Oh yeah, I should have made that a little bit more clear. These are all measuring in millimeters, so this is 1 centimeter. We could write it as 2.42 centimeters if we wanted it, if we divided it by 10. Hopefully that makes a bit more sense. And the calipers will have all different measurements. Some calipers you'll see will say 0 and then 1 centimeter and 2 centimeters and 3 centimeters. This one just happens to measure everything in millimeters, which is fine. All right, let's do part B here. What type of object do we have in here? I don't know. We'll pretend there's something in there. We're measuring something that's looking fairly small. Again, this is 10 millimeters or 1 centimeter, depending on how you want to think of it. We need to figure out where our 0 lies. So if I start looking, it doesn't quite make it to 1 centimeter. So I need to count how many marks. So right here in the middle is 5. This one's 6, 7, 8, 9. So it's at the 9. So I know for sure I have 9 millimeters. And then just looking really carefully at where the 0 falls between the 9 and the 10, if I had to just roughly estimate, I would say it's almost exactly in the middle. So I know that when I start looking at this scale here along the bottom, I need to probably be looking somewhere in between maybe like 4 to 6 range for my exact lining up. So if you guys want to kind of estimate your best to figure out exactly which one's lined up the best. So I know I'm looking in this sort of range here. I can see the 4 doesn't quite line up, so I'm going to forget the 4. The 5 is looking pretty good. The 6 looks like it's a little bit to the left of this line here, and the 4 was a little bit to the right of the line. So I'm thinking 5 is probably where it's at. And Avery, Alex, Damon, Anna, Bria, we're all agreeing, Taylor as well. We're all agreeing it's looking like 5. So to the 9 millimeters I started with here, because I'm using a caliper, I can measure this really accurately, and I'm going to add to it 0.5 millimeters. So half a millimeter. That's not a very big thing. So in total, I have 9.5 millimeters. Now, at the rate you guys were all answering these questions, it seems like you guys are getting a pretty good grasp on this. So if you have this printed off, awesome. If not, you can just look up here. Maybe I'll go through these with you guys. So if you didn't print them, you don't have to worry about it, and I don't have to post up solutions later because I don't think I have a solution sheet. So I'm going to give you guys maybe, I don't know, like we have 1, 2, 3, 4 questions, maybe like 2 or 3 minutes to go through these. So if I can get Mr. Ross maybe to just blow these 2 up to start, and that way if you don't have this printed off, you can kind of look at it and see what you can do. We'll start at number 1 there, and I'll kind of scroll down after a minute or 2 and give you guys a chance to do number 2, 3, and 4. So go ahead, spend a couple minutes figuring out these 4 questions. So while you guys are going through this, if you want to just write the number and your measurement in the chat, and we'll see if you are in agreement with others or if you kind of have a different number altogether. So power and numbers, we'll see if everybody kind of is on the right track, and I'll go through them real quick at the end. So if you just want to write number 1, this is my measurement. Number 2, this is my measurement. So Abby's writing in millimeters and Alex is in centimeters. That's fine. Those are the same numbers. Looks like you guys are kind of in agreement. 14, number 2, 1.96, 18.7, 19.6, 19.6, 15.4. We're all in the right ballpark. Now, on an exam, you likely wouldn't get a question that had a bunch of answers that were like grouped really closely together. So you wouldn't get like a 19.6, a 19.7, a 19.8, and they're all gonna kind of be spaced out just a little bit. Here's number 3. Got a 13.1 for number 3. And 14.3 for 4. We got a 12.1. Abby, it's hard to say. There's no sort of sort of rhyme or reason to what they would put the answers in. Sometimes if they want to be really cruel, they'll give you a caliper that measures in millimeters, but then all the answers will be in centimeters. So you have to kind of do two steps, you know? They're going to make you test your ability to read a caliper first of all, and then your ability to convert from millimeters to centimeters, which is kind of silly, but that's just kind of the way that these things work. So I don't know why they do these things the way they do, but that's the way they do them. So this is the last one, number 4. Everybody wants to have a look at that, see if they can figure that one out. I think everybody's pretty happy with 13.1 for 3, so that's looking like a good one. Number 4.